Hello everyone. In this video I'm going to show you how to apply feature scaling to datasets using Rapidminer. We already discussed about the topics, about the theory of these topics, but just to give you a context, we can say that one of the data preparation steps in data analytics is feature scaling. And we will now cover two feature scaling methods, namely normalization and standardization. So basically, feature scaling means changing the scale of one or more dimensions of the data that you have. Okay? So in particular, normalization is the procedure of rescaling the dimensions of your data so that the values fall between 0 and 1. Standardization, on the other hand, which is also another feature scaling technique, it is also called Z-score transformation, by the way. What it does is to rescale the features in a way that the mean becomes 0 and the standard deviation becomes 1. So let's go ahead and check how we can implement this on Rapidminer. So I'm going to require a dataset. I will just load the iris dataset here, because I would like to show you both normalization and standardization at the same time. Let me also use a multiply operator so that I take multiple instances of the same data to exemplify the differences between those. And what I'm going to do is to use a normalize operator for both for normalization and standardization. Okay, I will also leave one output of the multiply as a direct output for the process so that we can see the original dataset as well. But let's take a look at the parameters of the normalize operator. Here we have by default a Z transformation method is selected as the method for normalization. So that already indicates standardization. This is not something that I want right now. I want the range transformation, because normalization is the process of rescaling the attributes so that the values fall between 0 and 1, right? So we want range transformation for normalization. I'll drag and drop another normalize operator, but this time I'm going to leave the method for normalization as Z transformation, which already indicates standardization, right? Therefore, I can also change the name of this block so that it represents it better. Now I'm going to run this process. In the end, I'm going to have 3 tables. Okay, so the first table is the direct outcome from multiply. This is my original table. If I go and check the statistics, I see that we have 4 values, 4 dimensions, and those dimensions range between multiple values. So they're not standardized, they're not normalized. I can also check a box plot representation here to see the ranges, to see that the ranges are quite different from one another. But let me go to the normalized dataset. In the normalized dataset, if I check the statistics part, I see that the minimum values are 0 and maximum values are 1. These are set to 1, okay? And if I check the visualization by using box plots, I see that the upper part of this, the upper limit of the box plots are set to 1 and the lower part is just 0, which shows me, just directly shows me that the range is between 0 and 1. In standardize, we don't have the scales like that. So what the standardization operation really does is to set the mean of the attributes to 0 and the distribution of that in a way that it has one standard deviation. Okay. So we cannot see it by these lines, because these lines show me the medians, not the means. But apparently these are the means of the data. Okay, so the mean is set to 0.